afternoon and welcome to my YouTube channel. Today's lesson I'm going to be talking about histograms, mainly because my year 10s have got to be doing learning about histograms at the moment, so I wanted to make sure there was something to support their learning. I have got some histogram questions. It's not going to be a PowerPoint presentation today, just a series of histogram questions I'm going to explain and why we use histograms. I'm going to go straight over to the whiteboard, be going through histograms. I hope it's useful to people. I don't expect people to join me live. If they do, I'll try and say hello if I spot you're here. But it's going to be something that people can be directed to after the event, especially the students I teach. I'll be pointing them in the direction of this if they're having any trouble with the histogram stuff. So, without further ado, let's get straight on it. So the first question I imagine a lot of people are asking is why histograms? What are they and what are they about? Because normally in a bar chart, we would go along, and I've already done videos about the fact that bar charts are different from frequency bar charts. In a normal bar chart, you must have a gap between the bars and have labels down here saying what they are. In a frequency bar chart, that's no longer the case. You're going to have a number line, so 0, 10, 20, 30, which serves a purpose. It's absolutely fine, and it allows us to draw midpoint mountains, I call them, or frequency polygons. However, I'd like you to imagine for a second, because we always have frequency up the side, I'd like you to imagine that instead of standard gaps, when we collect the data, they only collect the data from 0 to 20-year-olds, then 20 to 25. For some reason the group sizes are changeable, and then 25 up to 30 and 30 to 40. Now, the reason it's important to show you this is if you have 4 people in this group, 6 people in this group, 3 people in this group, and 8 people in this group. When I do my 1, 2, 3, 4, 5, 6, 7, 8, when I draw my graph, 1, 2, 3, 4, that's 4, that is 6, this is 3, and this one is 8. And the problem comes here. Our eyes don't function on height when the bars are different widths. Our eyes naturally look at this and go, the biggest region here is the 0 to 20, even though it's not as high. In fact, this region here is bigger. There's 6 people in that group, but because of the nature of our eyes and how our brains work, we are trained to view area. In fact, if it was in 3 dimensions, we'd see it even bigger. This is way back to when we were hunter-gatherers, knowing the size of things. We're naturally inclined to see the size of things as area or even volume. In 3D, we'd look at the whole volume of it. So when we come to doing the reason we do histograms is to adjust for this and say, wait a minute, in a bigger region, we need to use something called frequency density. Density is something which should be being discussed an awful lot in lockdown. Unfortunately, governments and media don't like to use complicated maths words, and they instead focus on just pure numbers. Realistically, if we're going to look at lockdown properly and COVID-19 effects in different countries, we would also be looking at the density of the populations. We'd be looking at how close together people live. We're looking at how many people there are per million that get the disease, how many people per person who got the disease dies. It's the various different densities of information. But frequency density basically means what the total is between the space it was allotted. Because if it's a larger space, so you can see this space is 20 and this space is only 5, we call this the class width. 6 in a class width of 5 is much bigger than 4 in a class width of 20 because it's much more spread out. So what we do is we take our frequency and we divide it by the class interval or width. that is the space between 0 to 20 would be 20. And each of these numbers would have a class interval, and I'm going to change to a thinner pencil so we can see this. So what we've got here, the frequency density is 4 divided by 20, 6 divided by 5, 3 divided by 5, and 8 divided by 10, giving us 0.8, 0.6, 1.2, and 0.2. So these frequency densities we can then adjust for. Now let me rub out my random bar chart so I can draw it all next to it. We're going to use a scale again, but this time we're using the frequency density. 0, 10, 20, 30, 40, just like we did before. But for a histogram, we care about the frequency density and not the frequency up the side. The frequency, just to clarify, this frequency is the area of these bars, because that's what we're going to be looking. So the frequency becomes the area, and the frequency density is what we're going to look at. So we've got these new numbers, 0.2. So we look at all the numbers and it goes up to 1.2. So 0.2, 0.4, 0.6, 0.8, 1, 1.2. I work out that scale based on the numbers that I'm going to need. So I get the numbers first, get my scale numbers first. So between 0 and 20, it's 0.2. So that's going to be there, and you'll see that makes it much smaller than before. Between this one is 1.2. So actually, it's got the highest density of people. And what this means is, even though it's 0.8 here, that bar is bigger because it's got 8 is the area. Remember, it's the area that is the frequency in a histogram. And this one was 0.6. And that's 3. Even though this one will be higher because it's got the highest density of people in a given space. And I mentioned earlier about lockdown and COVID-19 and things like that. The number of people in a given space is massively relevant, because the more people, this is why schools need to be careful opening too quickly or too much, because if a school opens, there's a lot of people in a very small space, so the disease is more likely to spread. So this is why we have to be careful understanding the difference between frequency and frequency density. And you'll see it's still similar, but it's just adjusted which ones are the tallest and which ones aren't. I will still shade it because I still think it makes it look pretty, and why shouldn't our maths look pretty? But what we've done here is this one is a histogram, where this one attempts to be a bar chart, and it's not as useful. We prefer the histogram because our eyes naturally see area, and here we try and avoid this. So what I'm going to try and suggest is try to avoid that version. So what I'm going to do today is do a few questions. Hi Izzy. Hello Susanna. What I'm going to try and do is go through a few questions just to make it clear how this would work. So this question says, the table shows the heights of 20 people. Complete the table to show the frequency densities, rounding your answer to one decimal place. Now, the first thing I've taught you is that frequency density is your frequency divided by the class width or class interval. So what I like to do is I like to write in the thing what the class width is. 5, 15, 10, 10. And all I've done there is taken the two numbers away from each other and said what we're dividing by. I think it's useful then to write down the calculation. So I'm going to bring in my calculator. I have done 4 divided by 5, 9 divided by 15. Now I can do these in my head, but I want you to see what I'm doing. Because I've got a few divided by 10 here, they're straightforward, 0.1 and 1.3. 4 divided by 5 is 0.8, and I can tell you this is going to be 0.6, but let me just demonstrate. 9 divided by 15 equals 3/5, which switches to 0.6. So you're allowed a calculator for most of these, and it says one decimal place, and all these are one decimal place. So what I've done is I've completed the table. So notice I will do this a lot with higher tier questions. Once I've finished, I go back through the question. It shows 20 people. Okay, I'm going to add that information. Anytime I've got information, I add it. It shows 20 people. Someone's trying to call me while I'm working. That's helpful. Complete the table to show the frequency densities, rounding your answer to one decimal place. Okay, so we've now got next. That's thrown me a bit. Carry on. I wasn't expecting a call during a live thing. Okay, then the next questions. Let's change it up. We're going to go to the red one. So this one says the histogram below shows the distribution. Distribution means how the heights are spread out of 900 people. Now notice this time it's given us the frequency density and it's given us a histogram. One thing I taught you, one of the key things I've taught you from the start of this video today, is that the area or the frequency is the area of the square. So if we look here, we can spot first of all just the heights of these things. The frequency density, that is 22. That is 25. That is 20. And so is that. So we've got our frequency densities, because that's what that is. And if we want to know what the frequency is, we're going to need to multiply the area. So the other thing I do is I write the class widths. 15, this is just the widths of each of these, the gaps in each of these classes. That makes that, if we want to go to frequency, we're going to times them, because to undo division, remember, frequency density is equal to frequency divided by class interval. I try and hold dear to everyone that to reverse things, to work backwards, if we want to know what the frequency is, we're going to need to times, because it's the opposite of dividing. So therefore, I've got 22 times 10 is 220. 25 times 15 is 250 plus 125 is 375. 100 and 200. It's 900 people. Let's check that adds up. I must have gone wrong somewhere because it says 900 people, but that doesn't add up to 900. So where have I gone wrong? 5 20s. Have I got all the right numbers? 22 10s. How many numbers am I short? This adds up to 95. I reckon what it is, it's not quite the right number. This must be 22.5, and that's 225, because it's the only way I can see that this number would not add up. So to make it add up properly, that now is correct, and it adds up to 900. So notice how even then I checked the answer to see it should have been 900. I must have made a mistake, so I've looked at it, and it must be that I've rounded that slightly incorrectly. So I've been as careful as I could with it. I haven't seen any more questions in the chat. If anyone does join and wants to ask any questions, feel free to. If you're coming to this and it's not live, put questions in the comments below the video. More than happy to answer questions. Or you'll also get an opportunity to email me at the end if there's any further questions. The table below shows the height in metres of 1,000 trees. Clearly Mr. Beast's been around, he's planting all his trees again. We've done 10 to 25. We've done 25 to 30. We've done 30 to 40. What it wants is the missing bar. So we need to do this one. So we need to know what the frequency density is. Remember, frequency density, I say this each time because I want it to go in, is your frequency, I call it freq, divided by your class interval. I only need to find one here. I believe it's 10. So we're going to do 257 divided by 10 is 25.7. So I'm going to find where 25.7 is. It's about here. And that's going to be my final one. I'm using a different colour just so you can see how it's been added to the blue ones we've already done. And I'm going to shade it in just to show this is the new one. I like to have a nice shaded histogram. So you can see, again, all I've done is done it to fill in the missing bit. I'm trying to make sure we all understand what's going on. Here's our final effort at a histogram and how we can draw one. We're starting from the beginning. The test scores from students in a school, doesn't tell us the number unfortunately, are summarised. We've got 0 to 30. Now this is a nice little trick you can do. 0 to 30, put a little notch at 30. 30 to 40, 40 to 50, 50 to 70. This will tell you where your bars are going to be. So just to get yourself organised, Then it's find the frequency density. Remember, frequency density, you're probably able to say it with me now, is your frequency divided by the class interval. In order to do so, I often like to record the class interval early. So let's do that. We're going to write down 30. We're going to write 10, 10, 20 and 30. So when we do the division, 15 divided by 30 is going to be 0.5. 22 divided by 10 is 2.2. 28 divided by 10 is 2.8. 1.5. And 9 divided by 30 is the same as 3 divided by 10, so it's 0.3. So we've got all our numbers. So we're now going to draw it into the table. 0.5 is from 0 to 30. 0 to 30 is 0.5. So 0 to 30 is 0.5. Remember, if you're struggling with any of this, practice. Draw lots of them. In the description below, I've linked worksheets on Corbett Maths, which are brilliant. I've stolen this question from the first one you do there. I've also borrowed a couple of questions from on another website that I found on Mr. Barton's Maths. I borrow questions because why not? We can share questions and it's helpful. 2.2 goes to there. 2.8 goes to there. And then I'll use my ruler because I haven't got a ruler on my thing, but you guys have, so you will make sure you use a ruler to make this look super fantastic. Then 1.5 is a bigger one, 1.5, and then the final huge one is 0.3. And we have here a completed histogram. Remember, if you're ever working backwards and you want to know what the frequency is from the histogram, find the area by multiplying the frequency density by the gap, and that will tell you what the individual frequencies are. That's how you work backwards and interpret them. This has been a brief lesson on histograms. I hope you found it useful. I've tried to explain it as best I can. Hopefully you'll be able to use it to improve your histogram knowledge, answer any questions. If you're in my class or any of the other classes from First Plat, then brilliant, you'll be able to use this to help you with your learning for this week. I've been Mr. Harris. You haven't. Thank you so much for joining me. Until next time, ciao.